Hello Math 152 students. In this video we're going to finish up 8.2, take a look at one more part of this example. So we wrapped up the example with the at least 19% overweight. We're going to change our wording a little bit in the next example. And we're still dealing with the exact same population. We're still dealing with a random sample of 90 children. Remember that if that sample size changes, you must recompute your standard deviation. But in this case, we've left it the same, meaning we're going to be able to reuse and not have to recalculate. But suppose that a random sample of 90 children results in 24 overweight children. What might we conclude? So the phrasing on this question is a little bit more open-ended than the previous one. The other one, what is the probability? We're answering a probability number obtained through StatCrunch, or if we were doing it by hand, finding a z-score and using the table. But this one, they want us to calculate a probability and then interpret that probability. So with this conclusion, you do want to explain your conclusions, reference a probability, use StatCrunch, but it's a little more open-ended. So the first thing we want to do is observe that this 24 overweight children is not a percentage. In other words, we don't yet have a percentage that we can compare to this 18.8%. The first step in this problem is to go ahead and obtain that percentage. So grab your calculators and let's go ahead and calculate our p-hat for this example. Here, all we need to do is calculate 24 over 90. Okay, so plop that in your calculator. We're going to have to do some rounding, and in this case, let's round to 4 decimal places. Okay, so I'm just going to put, because I'm feeling a little bit lazy here and not wanting to use the symbols, just p-hat, and we're going to do 24 divided by 90, and this is going to be approximately 2.667, and in comparison to our sample or our distribution for our underlying population of 18.8% of overweight children, this number is pretty high. Now, pretty high is also contingent upon comparing to the standard deviation. In other words, how high is too high, or how high is concerning, also depends on our standard deviation. So our standard deviation was approximately 4%. Meaning when I looked at StatCrunch, just to put those tick marks back up here, 27% is 2 standard deviations above. So the 26%, approximately 27%, is right at 2 standard deviations above. In other words, you're pretty far out in the tail to see that percentage. So what we want to do is calculate a probability involving that p-hat. But there's one thing that poses some problems for us. When we're looking at our slide and we're just talking about one p-hat, if you don't specify a greater than or less than to shade with your normal curve, you can't obtain a probability. This is a little bit different than what we saw in Chapter 6. In Chapter 6 with the binomial distribution, we did have problems that would sound similar to this, and we would say, what is the probability of obtaining exactly 24 overweight children? And for the binomial distribution, it was a discrete distribution, and we could obtain the probability for an exactly 24. In the continuous distribution for p-hat, we're using a normal curve, and probabilities translate to area under the curve. If you just have one probability and no greater than or less than, no shading, there's no area under exactly 1 point. In other words, you don't have an or equals to option. I can't just calculate the probability of exactly 24 overweight children. And in fact, that's not what we even want to do. What we're asking is, what is the chance that we see 24 overweight children or even something that's bigger? In other words, if we suspect that this p-hat is high, we want to justify it by saying, well, what's the probability that we see that number or something even greater? So we have to find some way to translate a single p-hat into shading that's either above or below. So we sort of have to tweak what we're saying in this example. And what we really want to know is, what is the probability that we see a p-hat of 0.2667 or even higher? Sometimes your book will say, or even more extreme. This is going to mimic what we do with hypothesis testing, where we look at the tails and we do right-tailed tests, left-tailed tests. We always have to think about, what is the probability of observing a statistic that's that high or even higher, or in other cases, that low or even lower. So if we phrase it like this and go back to StatCrunch, before I even modify this part, I can see that this is going to be a pretty small number. We're going to be looking at, according to the empirical rule, if we round to 27%, approximately 2.5%. So we know that 95% of the data is within 2 standard deviations, 2 below, 2 above. So that leaves 5% above the 2 standard deviations, or 2.5% for each tail. So I'm expecting to see roughly 2%, 2 to 3%. See what it gives us. So notice it's shading right there, a little above 2.5%. So we could say 0.028 or 2.8%. Oops, a little bit of a typo there. So what might we conclude? First of all, this would be unusual. It would be unusual if we were expecting to see 18.8% overweight to actually see almost 27% overweight. What might you conclude? Well, there's several things, and it depends on the context. And if you're doing a project, it depends on kind of what your hypotheses were, how you would interpret this number. For example, we don't know much about this sample. Maybe this sample was done in 2010, and we were comparing to 18.8% of overweight children observed in 2004. Well, maybe in 6 years from 2010, the percentage has actually gone up. So maybe we would say, this kind of gives weight to the idea that this 27% would be unusual in light of 18.8%. Would be unusual to see that. Maybe what's going on is it's not something happening with my sample, but maybe it's a shift in my overall population. Maybe that population proportion of 0.188 is no longer correct. Because if it were, I'd be kind of surprised to see this. So sometimes we go back and question our original assumptions to see maybe something's there was wrong, or maybe this sample was from a particular region that didn't match the underlying population. Maybe there was something going on with our sample that was a little bit different. So sometimes your interpretation or your answer to this question depends on your context. But what I would want to see you do is calculate the p-hat, calculate the probability of that number or even higher. In this case, looking to the right. If it was lower than your percentage, you would calculate less than. And then think about what that means. So let's just write a quick summary. So I could say something like, seeing approximately 27% of our sample overweight, I'll go ahead and include or more in here, 27% or more of our sample overweight would be unusual. Maybe the 18.8% overweight is no longer valid. sure we have something going on with our sample. Okay, so we're going to leave that a little bit open-ended at this point, and this is the type of thinking we're going to be doing going forward in chapters 9 and 10. All right, so just a couple of observations to finish up our 8.2. 8.2, you are going to be doing a little bit more work in calculating your population standard deviation, and you're going to be toggling back and forth between percentages and proportions, and you're also going to be getting probabilities. So there's a lot of small numbers, and you want to try to write out as much as you can before you get started. For example, check your conditions, write out your mean, write out your standard deviation, and then use StatCrunch. I think it's often helpful as you're working these problems to either draw your normal curve and do some shading, or if you're working a bunch of StatCrunch problems, take a screenshot or copy and paste your graphs so that you just have a record of how you computed that number. So let's go back to our PowerPoint and do a little bit of summary. Quick recap of Chapter 8. The big question is, can I use a normal distribution for my data? And then question number 2, do I have means or proportions? When we're just in 8.1, we were just looking at sample means. 8.2, just sample proportions. But when we proceed, we're going to be mixing those up, and you want to make sure you can identify which set of conditions and which set of formulas to use. So let's recap that part. Sorry guys, wrong direction there. For means to start off, your criteria is greater than 30, or if you're less than 30, your underlying population is normal, or if you're less than 30 and you don't know anything about your population, your box plot and QQ plots check out. Then, once you've satisfied the greater than 30 or one of the small data set conditions, you've got your formulas here that you need to use before you can go to StatCrunch. For proportions, the criteria you want to check is the n times p times 1 minus p and the 5% condition. Once those two check, you can say your sample proportion is normally distributed and you have your formulas for your mean and your standard deviation. These two slides are a pretty good recap of our chapter. You want to kind of print these out and maybe have them handy as you are working on your problems. So that's it for now. Work on your My Math Lab problems. Let me know if you have questions.